So before starting the problem, let's give me some introduction about the line coding. Okay. So as you all know, the data that is transmitted over the transmission channel has to be converted to signals, right? So at the physical layer of the network model, the data will be represented in the form of bits. So these bits cannot be directly transmitted over the transmission channel, isn't it? So you have to convert the data into signals, right? So the signals can be in the form of analog or it can be in the form of digital. Okay, so today's topic is the converting digital data to digital signals. Okay, so when I say digital data, that means what? It will be zeros and ones, right? So when this data need to be transmitted over the transmission channel, this digital data has to be converted into digital signals. Okay, and you know, digital signal is represented in this form. This is already discussed, right? So now the method or the process or a technique followed to convert the digital data to digital signal is known as line coding. Okay, so this underline coding, that means to convert the digital data into digital signals, many methods are followed. Okay, so the first method that we are going to discuss is unipolar, second method is polar, third method is bipolar, fourth and fifth is multi-level and multi-transition respectively. But in your syllabus, you got to study only unipolar, polar and bipolar. So we are not going to study these two methods, that is multi-level and multi-transition. So let's start with the first method under line coding, that is unipolar. Okay, so unipolar, again this is a method used to convert the digital data to digital signals, and the method under this we are going to study is NRZ, that is non return to zero. Okay, let's see what is this non return to zero. See, in this method, in unipolar, okay, this digital data has to be converted into digital signal. Okay, now what are the rules need to be followed here? So here, the data, this is bits, whatever bits or the data given here has to be presented either above of this zero axis, I mean x-axis, or it has to be presented in the other side of the x-axis, either positive side or it has to be negative side. Okay, so either one side you have to present the data. So consider this is the data given and you have to convert this data into digital signal. So the rules you need to follow under this method is whenever there is a zero bit, then it represents zero voltage. Okay, that means this x-axis, this reference level you have to mark. And whenever one is there, you have to consider the positive side of the reference level. Okay, when there is zero, it is zero voltage. When there is data bit is 1, then you have to mark it at the positive side. Okay, let's see how to convert this data into digital signal. So as I said, the given data is what? 1 0 1 1 0 1 0 1. Okay, so the for which I have written x-axis, that is with respect to time, y-axis will be in the term of amplitude. Okay, so y may be the levels. Okay, so whenever the bit is 0, you have to mark it 0 voltage. Whenever bit is 1, you have to mark it as positive voltage. So let's start drawing the digital signal. Okay, in the given data, the first bit is what? It is 1. So which side I have to mark it? At the positive side. As you know, this is positive side, right, in the presentation, and this is negative side. Okay, so this is 0. Okay, so when there is 1, you have to mark it at the positive side. Okay, when there is 0, you have to mark it at the reference level, that is 0. Next bit is 1, so 1 here at the positive side. Next bit is 1, so again it should be marked at the positive side. Next is 0, 0 voltage. Next bit is 1 at the positive side. Next bit is 0, that is at the reference level, and next bit is 1, that means positive side. So this is how you need to draw the digital signal for the digital data. Later on, you have to join all these lines. So once you complete that, the signal will look like this. Okay, I'm just joining these lines. After joining this, you will get the digital signal in this form. Okay, and let's consider another example. Okay, so the given data is what? 00 100 10 10. This is the given data for which you have to convert this data into digital signal. So what is the rules you have to follow? Since it is a non-return to 0, 0 bit is there, then mark it as 0 voltage. If 1 bit is there, then mark it as positive voltage. Okay, so 0 in the sense it is 0 here. For this 0, again it should be at the 0. Okay, when there is 1, you should mark it at the positive side. Okay, and then 0 again at the 0 level, and the 0 when there is 1, again mark it to positive side, and then 0, and then 1, and then 0. Okay, this is the digital signal for this given digital data. Okay, so that is I have clearly drawn here. See, the for this digital data, this is the digital signal. Okay, so I hope this problem is clear to everyone. To convert the given digital data to digital signal using unipolar scheme, wherein we are following non-return to 0. Is this clear to everyone? Yes?
Yes, ma'am.
Okay, then
Ma'am,
we'll
should
move
we draw
on.
both the diagrams, ma'am?
No. You just
Only
need
the
to draw.
final one is. Yeah.
Yeah.
Okay.
For this data, you just draw this part. That means this final one. Okay. So this is I have
Yes, ma'am.
considered for the explanation purpose. Okay. Okay. Next, we'll move on to the next method under line coding scheme, that is polar. Okay. So in polar, there are three methods, that is non-return to 0, return to 0, and biphase. So these are the three methods that we are going to study under this polar technique. Okay. So let's start with non-return to 0. Okay. Under this, again, we have two types. One is non-return to 0L, that is non-return to 0 level. The next one is non-return to 0I, that is non-return to 0 inverted. So let's start with NRZ. Okay, so let's start with the first one here, that is NRZ level. Okay, so when this method is followed to convert the given data to digital signal, then the rules you are supposed to follow is when there is bit 0, you have to consider it as a positive voltage. Okay, when it comes to the data bit as 1, then you have to consider it as a negative voltage. Okay, so this is the positive side, right? And this will be the negative side. Okay, so for this data, you have to convert it into what? Digital signal. So let's consider that the same problem. So when there is Z, which way have to mark? You have to mark it at the positive side. So this is the reference level 0. This is the positive side and this is the negative side. The first bit is 0, right? So which way I'm supposed to mark? At this place, positive side. Next bit is 1. So you have to mark it as the negative side. Next 0, positive side, next bit is 0, again positive side, next bit is 1, again negative side, again next bit is 1, mark it as the negative side, then next bit is 0, mark it as the positive side, and the next bit is 1, mark it as the negative side. Okay, so all together you will get the data signal as in this way. Okay, so this is the digital signal for this given digital data. Okay, you have to remember these things. Then it will be easier for you to solve the problem. Okay, so in the previous class, I mean in the last class, I just explained the theory part. So now I'm explaining the problems following that theory. Okay, whatever theory was given, I have made it as a point here. With respect to that, I'm solving the problem. Okay, I hope this is clear. So next, uh, for the same method, the problem, the given bit is 1011010101. Okay, for this you have to draw the digital signal. So the same 1, mark it at the positive side, 0, sorry, 1 at the negative side, 0 at the positive side. Okay, so this is the solution. 1, see here I marked it at the negative side, for 0 at the positive side, and the same thing I followed for all the bits. And at the end, okay, once again, second, I'm not able to change the slide, just a minute.
Ma'am, you're on mute.
Oh, I'm sorry. Let's start with the second type under non-written zero. That is non-written zero invert. Okay. So in this method, you have to remember these two. Okay. So when there is the given bit, data bit is 0, then there is no transition in the signal. Okay, and when there is the given data bit is 1, then there will be transition in the there will be transition in the signal. Okay, so consider this is the given data for which you have to generate data signal. Okay, sorry, digital signal. Okay, so as I said, yeah, 0, yeah, I have written example here. Let's consider that. The same data I have considered. See here, when there is 0, then no transition. See here, since the first bit is 0 here, you can start from the positive side. Oh, sorry, you take it as positive side here, and this as a negative side. Okay, so it's not compulsory that you have to start from the positive side itself. Okay, so this method only talks about the transition, right? So either you can start it from the positive side or or from the negative side. Okay, so I'll start with the positive side. Okay, the first bit is 0. Either you can start from the negative side or the positive side. Okay, but I'm going to consider here positive side. So the given first bit is 0, right? So I'll start from here Okay, so consider here only. Yeah, I'll start from positive side. That is this one. So when there is bit 1, see the next bit here it is 1. Okay, there should be transition, right? See this signal is at the positive side, as next bit is 1, you have to make a transition. That is, you have to move to the negative side. I hope this is clear to everyone. Okay, see for 0, no transition. I just started here. Okay, and I stopped here and I checked what is the next bit. It is 1. Okay, when there is 1, there should be transition in the voltage. That is, you have to move from the positive side to negative side. Okay, next, consider what is the next bit. Again, it is 1. There should be transition, right? So if the signal is at the negative side, you have to move to the positive side. That is what it says. Okay, next bit is what? 1. 1 means no transition. You have to stay in the positive side itself. Okay, next bit is 1. So you have to, since you ended up here at the positive side, since it is the next bit is 1, you have to move to the negative side. Okay, again next bit is 1, you ended up here at the negative side, move to the positive side. Okay, again next bit is 1, here you ended up at the positive side, again move to the negative side. Okay, and the last bit is 0, no transition, so you stay in the negative side itself and draw the signal. So this is the digital signal for the given input digital data. Okay, that is what I have drawn here. Okay, is this clear to everyone? Non-return to 0 in what? You understand this?
Yes,
Yes?
ma'am, understood.
Yeah. I'll move to the next example under same method. In what? Okay. For 100111100. Okay. So for this, 0 means no transition, 1 means transition. See, first bit is 1. Either you can start from the positive side or from the negative side, but I'll start from the positive side. Okay. 1 means transition, right? I've just drawn here. Okay. Huh. 1, I'll just here only is that right? 1, it started here, next bit is 0, so I'll stay in the same side of the in the presentation, and again next bit is 0, again I'll stay in the same side, and fourth bit is 1, you have to make a transition from the positive to negative. Again next bit 1, again make transition from negative to positive. Okay, again next bit 1, make a transition from positive to negative. Okay, and next bit is 0, stay in the same side because no transition. Again next bit is 0, again stay in the same side. Okay, this is another example for non-return 0 invert. Okay, let's summarize. uh, See, I discussed till now unipolar, okay, in which we completed non-return to 0, where 0 represents 0 voltage, 1 represent positive voltage. Next method, we started with polar, where you have the first technique as non-return to 0, where we discussed non-return to 0 level, where 0 bit represent positive voltage, 1 bit represent negative voltage. Then we moved on to the non-return to 0 invert, where 0 means no transition, 1 means there is transition in the signal. Okay, so this is what we discussed. Under polar, I just completed non-return to 0. So next method is what? Under polar scheme only, you have next method, that is return to 0. Okay. See, in this method, again, do remember, even this method is also used to convert digital data to digital signal. Fine. So what is the rule you need to follow here while converting digital data to digital signal? That is transition in the middle of the bit. Okay, do remember there will be transition in the middle of the bit. Okay, so if you need to convert bit 0 to digital signal, then you have to start from the negative side and make a transition in the middle of the bit. Okay, this is other way writing z, right? So other way z. Okay, so start from negative side, make a transition in the middle of the bit. Okay, so this is to represent 0. So when there is a data bit 1, how to write the digital signal for that? For that, you start from the positive side and make a transition in the middle of the bit. Okay, that represents 1. Okay, when there is 0, other way writing z, and when there is 1, you are going to write it the actual z. And 0 starts from negative side, 1 starts from positive side. Okay, you have to remember this. Then drawing digital signal for the given data is very easy. Okay, so let's start solving this problem. Consider the given data, digital data is 1011001. Okay, what is the first bit? It is 1. So 1, that means you have to start from positive side. How do you write it? So the direct way of writing Z. You start from the positive side, make a transition in the middle of the bit and end it here. Okay, the direct way of writing Z. When it comes to 0, start from the negative side and make a transition in the middle of the bit. So that is, see, it is 0, right? So that's why I'm starting it from the negative side, and I've written other way of writing Z. Okay, other side of the Z. Okay, next bit is what? 1, right? How do you write the 1? Start from the positive side, make a transition. Okay, again next bit is 1. Start from the positive side and make a transition in the middle of the bit. And next bit is 0, start from the negative side and make a transition in the middle of the bit. Again next bit is 0, start from negative side, transition in the middle of the bit. And the last bit in the given data is 1, start from the positive side and make a transition in the middle of the bit. Okay, if you write this, then after writing this, you just complete the line. Complete this line, complete this line, and again complete this line, and this, and this, and this. Okay, once you complete that, your digital signal will look like this. Okay, so if you remember this part, okay, you can write the digital signal for any digital data aram se. I mean, easily you can write. Okay, I hope you followed this. Next, let's solve another problem. uh, Starts with 0. Okay, when it starts with 0, you have to start from the negative side, right? And other side of the z, this way. 1, start from the positive side, make a transition. Okay, then it is 0, again negative side, again 0, negative side, right? Again 0, negative side, then 1, positive side, right? And then 0, again negative side, and then 1, again positive side. Okay, and then you just complete this line that will give you the required digital signal for the given digital data. Okay, so I've just redrawn here. See here. So this is what? This one. Okay, I just drawn these lines, and the final digital signal will be this for the given data. Okay, so that is all about return to 0. Okay, next. The third method under uh, polar, right? So that is Manchester, right? So let's see how to represent data bit 0 and data bit 1 for this method Manchester. Okay, the rules you need to follow here. Actually, Manchester is the combination of RZ and NRZL. Okay, so RZ says what? There should be transition in the middle of the bit, right? NRZL says what? 0 is, you can see here, NRZ, NRZL, right? Yeah, 0 means positive, 1 means negative. Okay, so that is what, second. So 1 second, I got stuck here. Yeah. Okay, so here 0 means positive, 1 means negative, right? As per NRZL, 0 bit it is positive, then 1 bit is negative, right? So let's start how to represent this. Okay, so when there is 0, you start it from the what positive side, and since it is RZ, there should be transition from the middle of the bit. Okay, it starts from negative, ends at the positive side. 1 bit representation. Okay, next, when it comes to 1, data bit 1, it 1 is what? From negative to positive. From negative to positive. That means there is a transition in the middle of the bit. It follows both the logic of RZ and NRZL. Okay, there should be transition in the middle of the bit, and 0, when the given data bit is 0, the transition from the positive to negative side. When the given data bit is 1, then the transition should be from negative to positive side. Okay, so let's solve the problem now. Consider this is the given data and you have to solve it using Manchester method. 0 1 0 0 1 1 1. Okay, so okay, yeah, let's start. Okay, let me consider this only. So 0, right? When there is 0, what you have to do? You have to move from the positive to negative, right? So you start from the positive and make a transition in the middle of the bit till the negative. Okay, next 1. 1 represents what? From negative to positive. Okay, 0 from positive to negative. Okay, again next bit is 0, positive to negative. Okay, again next bit is 1. 1 is what? Negative to positive. Again next bit is 1, negative to positive. Again next bit is 1, from negative to positive side. Okay, so all together complete drawing the lines here. Okay, so then you will get the final digital signal like this. Okay, so you just need to remember this part. Fine, so that is one example for Manchester. So let's consider another example, 1 0 0 1 1 1 0 0. 1 in the sense you have to start from the negative side. Start from here, move to the positive side. When there is 0, start from the positive side and move to the negative side. So that is what drawn here. Start from 1, start from the negative side and move to the positive side. 0, start from the positive side and move to the negative side, and the same will be followed for all the bits. So at last you will get this as a digital signal. Fine. So that is one more example. So the last method under biphase is differential Manchester. So this differential Manchester follows the logic of return to 0 and NRZ inversion. Okay, so you have to remember the logic of Z, RZ. What does it mean? there is a transition in the middle of the bit. Correct. Next, what is non-written zero uh, inverted? What does it mean? So the logic that is followed under invert, you have to follow. Okay. So let's non-return to zero invert. Yeah, here. What does it mean? Zero, but then no transition. It has to stay where the signal is there. If it is in the positive side, it has to stay there. If it is in a negative side, it has to stay in the same side, right? When there is data bit 1, then there should be a transition. If the signal is at the positive side, it has to move to the negative side. If the signal is at the negative side, then it has to move to the positive side. Okay. So let's continue. No, differential Manchester. Yeah. Okay. So now to represent 0, if the given data bit is 0, then you can present it either way. Start from the negative side and stay at the same side. But there should be a transition in the middle of the bit. Okay, because that is the rule under return to 0. So as it says, return to 0 says there should be transition in the middle of the bit. Whereas NRZI says when there is a 0 bit, then there should not be any transition. So the signal starts from one side and then remains at the same side. Okay, either you can represent 0 bit this way, or you can start writing the signal in this way. That means you can either start from positive side, or you can start from the negative side. That will be depend on the signal. Okay, this is when you are supposed to represent the data bit 0. Let's consider when the given data bit is 1. Then when there is 1, there should be a transition, right? If it is in the negative side, it has to move to the positive side. If it is in the positive side, it has to move to the negative side. And another rule is what? There should be transition in the middle of the bit. Okay, that is why it is represented here. So now we'll solve one problem, then you will understand it better. Okay. So now the given data is what? 10100. This is the given data. Now you have to convert it into digital signal. So which is the first bit? It is 1, right? See, the first bit is 1. Either you can start from the negative side or positive side. It's left to you. Okay. So I will start drawing from the positive side. The first bit is 1, right? So I will start using this one. That is 1, right? So from positive to negative, there is a transition, right? And which is the next bit? It is 0. What it says? Either you can use this one or this one, right? But you have to find where the previous signal is ended. Okay, the first bit signal ended at the negative side, isn't it? So you have to continue the signal. So for this you have to use this one. Okay, not this one. I'll repeat, the either way you can use, but the selection will be depend on the signal, the previous bit signal. See, for bit 1, this is the transition, right? So next bit is 0. Now you have to make a choice, either this or this. Depending on the previous signal, you have to make a choice of this representation. So I'll be considering this. Why? Because the previous signal ended at the negative side. Okay, so I'll be using this one. So it starts from the negative side and ends at the negative side itself. Okay, let's see that. Okay, it ended here and I have used 0 representation like this. Okay, next 1. Either way you can use to represent data bit 1. Okay, so but previous signal ended at the negative side, right? So I'll be using this one. Okay, so let's see this one I have used. There is a transition from the negative side to positive side. Fine. Okay, next bit is which one? It is 0. So you can use either way, but suitable one is what? The signal ended at the positive side. So which one you have to choose? You have to choose this one because it started at the positive side and ending at the positive side. That is this way. Okay, started at the positive side and ended at the positive side. Fine, that means no transition as per NRZI. The last bit is 0 here, right? So which one you have to use, this one or this one? You have to consider the previous signal. It is ended at the positive side, that's why I'll be using this one. Let's see that. Okay, see here the last bit I've used this representation of 0. Okay, I hope you understood. So you remember this, the other things are easy to write. Okay, so that is one example. Another example, let's start with first bit 0. Okay, as I said, you can start from the negative side or the positive side, that is left to you, but I'll be starting with the positive side. Okay, see, when you look at the textbook, you may be wondering how come they have used from the negative side. For few of the problems they have used negative side, for other problems they have started with positive side, right? So you have to remember this. You can follow either way for the first bit in certain methods. Okay, but it's not true with all the methods. Fine. So let's start solving this problem. The first bit is 0. So let me start from the positive side. So the first bit is this one. Okay. Second bit is 1. It is ended at the positive side. So I'll be using the first representation of bit 1. This one. Okay. So that means this here. Okay. Next. Third one. Third bit is 0. So the previous signal ended at the positive side. So for 0, which method I have to use? That is this one. So I'll be using that. You can see from here to here. I've completed. Okay. Next bit is 0. Since the previous signal ended at the negative side, so I have to use this one. Okay. So that is what started from here and ended at the same side. Next is bit 1. Which one you have to use? This one, negative side, right? So I'll just consider that. Start with the negative side. Fine. The last bit is 1. Again, see, the previous signal ended at the positive side, then you must make a choice of this, right? So that is what I've considered here and completed this digital signal. Okay, this is the digital signal for this given digital data using differential Manchester. Okay, so let's summarize what we discussed so far. Under polar, we discussed return to 0. Under biphase, we discussed Manchester and differential Manchester. Okay, that's all about the polar method. Okay, so do you understand till this point? Any doubts? Students, please respond. Do you have any doubts? If no, I can move on to the next method. Okay, I'll take that as no doubts. I'll move on to the next method, that is bipolar. Okay, so in bipolar, again you have two types, that is AMI and pseudo ternary. Anyways, the theory part I have completed in the last class, so I'll directly move on to the problem. Let's start with AMI, that is alternate mark inversion. This is easy method. Okay, again this is used to convert the given digital data to digital signal. Okay, so what are the rules need to be followed while converting digital data to digital signal based on AMI? So the first thing is what? If the given data bit is 0, then it represents 0 voltage. As you know, it will be marked at the reference level itself. Okay, next, the data bit, if the given data bit is 1, then how you need to draw the signal alternating positive and negative voltage. So this will be positive side and this will be negative side. So whenever there is one, if you start with signal this side, okay, then when you encounter again bit 1 in the given data, then you have to alternate it to other side. If you started with first bit 1 at the positive side, then the next bit 1 you have to mark it at the negative side, and next one is at the positive side, again next one is at the negative side. Okay, when there is 0 in the given data, then mark it at the level 0, that is reference level. Okay, this is how you are going to draw the signal. Then join all this. Okay, so when you complete this, you will get the digital signal. Okay, so that is what I have completed here. Okay, the simple one. Whenever there is 0, mark it at the reference level. Whenever started from positive side, then you have to mark the next bit at the negative side. As you know, this is negative side and this is positive side. Okay, simple one, right? The next one, another example, 0 0 1 0 triple 1 0, right? So 0 first bit is what? 0, right? So it will be at reference level only, 0 voltage. 1, let me start from the positive side. 0, again at the reference level. 1, you have to move to the negative side. Again 1, move to positive side. Again negative side and then 0. So this is the digital signal for this given digital data. Okay, that is what I have completed here. Okay, the easy one, right? So next one is pseudo ternary. Pseudo ternary is the second method under bipolar. Okay, so this is a variant of AMI. Okay, so here the other way you have to use, if the given data bit is 0, alternate it from the positive and negative voltage. If the data bit is 1, mark it as 0 voltage. Okay, so let's consider this data. First bit is 1, so as per this method it is 0 voltage, right? Next bit is 0, move to the positive side, and next bit is 0. So here it says alternating positive and negative voltage, so that you have to move to the negative side, right? And then 1 0 0 voltage, again 1 it is 0 voltage, again 1 it is 0 voltage, again 0. Since you marked it here as the negative side, move to the positive side and mark it. Okay, again next bit is 0, again move to the negative side. Fine. So this is the digital signal for this given digital data. Okay, that is what I have completed here, digital signal. Okay, last one example under this, the same thing. The data bit starts from 0. 0 means alternating positive and negative. 0, 1 means 0 voltage. Again 0 means negative side. Again move to positive side, right? Again voltage 0 and then negative side. So this is the digital signal for this given digital data. Okay, so let me summarize that we discussed here. Under AMI, that is alternate mark inversion, 0 means 0 voltage, 1 means alternating positive and negative voltage. Whereas pseudo ternary, it's the version, another version of AMI, where 0 means alternating positive and negative voltage, 1 means 0 voltage. Okay, yeah, that's all under this encoding technique. So